faithfully delivering value by interpreting great books from around the world. Hello, this is Sally Talking Books. Today, I'm breaking down the book, Math Taught by Mom. Back in the day, people said mastering physics, chemistry, and math means you can go anywhere without fear. Nowadays, there's a saying that those who grasp math rule the world. The importance of math is crystal clear, but math is a subject with stark polarization. Some kids pick it up easily and just keep getting better, while others never quite get the hang of it, and their exam scores suffer. Many parents wonder how to help their kids excel in math. Is it cram schools or endless practice books? Truth is, neither is the key. It's all about cultivating the right mindset. Math Taught by Mom describes how the author's mother started from life's little details to train his math thinking, benefiting him for life. The author, Sun-Lu Hong, showed outstanding math skills from junior high onward. In 1978, he was a winner in China's first mathematical Olympiad. After graduating from Beijing Normal University's math department, he taught at Beijing Experimental Middle School and was a homeroom teacher for elementary school math Olympiad classes. Using his elementary school diaries, Sun Luhong reconstructs scenes of his mother guiding him to explore math and unique learning tricks. Sun Luhong's mother wasn't some great educator. She didn't even finish junior high, but she sparked his interest in learning, accompanying him to experience the joy of exploration and the thrill of discovery. She successfully ignited his math talent, benefiting him throughout his life. Math is abstract. Kids' thinking struggles with abstract concepts directly. Add in all the jargon and logic rules, and just lecturing can fuel fear and resistance. Parents should turn life's everyday moments into math lessons, helping kids transform their thinking subtly. Next up, I'll cover this book in 3 parts. First, what educational philosophies are needed to cultivate math thinking? Second, how to use everyday objects to explore math with kids. Third, common problems and solutions in elementary math learning. First off, cultivating kids' math thinking. The book introduces 3 philosophies: sparking interest, finding the right learning methods, and parental companionship. The first and most crucial point is to spark children's interest. The interest we're talking about here refers to the child's innate drive to pursue knowledge. Once parents nurture or develop this drive, they can step back and interest will push the child forward on their own. In cultivating interest, parents shouldn't just focus on imparting knowledge from an academic perspective. So, instead, start from where the child currently understands things, spark their curiosity to explore so they can experience fun, engagement, and discovery. Maybe this process doesn't teach specific facts, but it cultivates the child's thirst for pursuing knowledge. For the math thinking, we're discussing how can we effectively spark children's interest. Let's look at Sun Luhong's example. On Sunday, Luhong's 10th birthday, his mom steamed a bun for him with a math formula on it. 3 plus 7 equals 10. March 7th is his birthday, and the 2 numbers add up to his age. That day, his mom also taught him a magical equation. 777 divided by the sum of 3 sevens equals 37. Then she asked him to try it. Calculate 999 divided by the sum of 3 nines, which also equals 37. This pattern holds all the way down to 111 divided by the sum of 3 ones. This amazing result had Sun Luhong obsessively studying birthday-related numbers all day, arriving at his own conclusion. The formula always equals 37 because 37 times 3 equals 111. This discovery thrilled him, making him feel like he was doing the same work as mathematicians. Actually, Sun Luhong's mom just threw out 2 equations closely related to his age at the start, and the rest of the exploration was entirely his own doing. I think at the end of that year when he was 10, his mom asked him to use the digits 0 through 9 to create two equations using addition, subtraction, multiplication, and division, one to bid farewell to 1973 and one to welcome 1974. Sun Luhong put in a lot of effort and actually figured it out. 1974, 1963 equals 123 plus 50 times 6 times 7 minus 4 plus 8 minus 9, and 1974 was also calculated using all 10 digits without repetition. These two formulas gave him special anticipation and confidence for the new year. In modern terms, it was full of ritual. Children are naturally extra curious about things related to themselves. For example, their own name, birthday. If what they're learning relates to them, they'll more easily develop interest and spend more time and effort to understand it. But when kids are willing to spend time playing with numbers, adding, subtracting, multiplying, and dividing, they'll remember this exploration vividly and stop fearing math symbols or even long equations. So, parents can use anything the child has experienced to cleverly weave in math elements, making acceptance feel more natural. Besides the most crucial interest, what other ideas help develop math thinking? Next up, the second point is to try to find math learning methods that fit the child best. Sun Luhong taught math at Beijing Experimental Middle School. He knows classroom methods are often standardized and one size fits all, which boosts efficiency and management. And a uniform approach helps over half the kids understand and master it. But does that mean the other half who didn't get it are dumb or incapable of learning? No, it just means the teacher's method didn't connect with what the child already knew in their brain. In other words, that method wasn't suitable for those kids. Take Sun Luhong's childhood experience. For example, he was careless since first grade. Teachers thought it was due to poor memory, so any teacher focusing on memorization paid extra attention to him. When learning the multiplication table, he was often called on in class to recite it. If he messed up, he had to stay after school and read it aloud.
Back then, he absolutely hated the multiplication table. Sitting in class felt like torture, and staying after school was pure agony.
Obviously, rote memorization of the multiplication table didn't work for Sun Luhong. You can imagine if this kept up, he'd only grow more resistant to math. That's when his mom came up with an idea. Play a finger game together.
One day on the way home from school, Mom casually asked him to hold out all 10 fingers.
Then, starting from the outer finger of the left hand, count to the fourth finger and bend it down. Now, with 3 fingers on the left and 6 on the right, it shows 4 times 9 equals 36. Can 5 times 9 be done this way too? Sure, just bend the 5th finger from the left. See if it leaves 4 on the left and 5 on the right. This finger game works for 1 through 9 times 9. Such a novel approach. The teacher never taught Sun Luhong this. That whole night, he was playing with the finger method for the 9's times table, and it got deeply imprinted in his memory. Fingers play a crucial role in brain development. Counting with fingers directly stimulates the brain to process quantitative changes, reducing fear of learning new things. After this, Sun Luhong even figured out finger methods for multiplying by 8, 7, and so on. The entire multiplication table was no longer a problem for him. Not only that, but his teacher noticed his unique approach and invited him to demonstrate it to the whole class. The recognition from his teacher and classmates became his motivation to keep working hard at math. So, the methods taught in class aren't necessarily the only way, and teachers' conclusions aren't always entirely correct. Parents should use their understanding of their child to help find suitable ways to explore math. Third, an educational philosophy that helps cultivate math thinking is that parents should play the role of a companion and curious learner, not an all-knowing expert. Parents always appearing omniscient. This has two downsides. First, children miss out on the joy of self-discovery. Believe that kids can uncover many mathematical patterns themselves, whether big or small, letting them experience the discovery process, feeling their thinking expand. and that aha moment is crucial. These experiences continually fuel children's motivation to learn. Conversely, if parents can't wait to tell kids what they know, children will think it's just adult stuff, normal, they don't know it, and they'll miss out on that sense of wonder. But you, another downside is it creates dependency. Kids ask parents for everything. Not only does their thinking skills go untrained, but parents may lose patience and give dismissive answers, killing the child's curiosity and exploratory skills. Learning isn't about giving kids answers to memorize. It's about them transforming book knowledge into their own through thinking and practice. For familiar knowledge, parents can learn alongside their children. For content we don't know, we can confidently let the child teach us. The benefits of doing this: the only way many parents can gauge their child's grasp of math concepts is by having them play teacher, explaining knowledge clearly in their own words and thought process. This builds confidence and reinforces learning. After establishing proper educational philosophies, let's move to part 2: how to use everyday objects to explore math with children. First, let's understand from a child's psychology perspective how children's brains process math. Based on his child psychology research and decades observing children of various ages, Sun Luhong identified 5 typical stages of how children comprehend abstract concepts. Take number comprehension as an example. Superficial stage. Numbers are just words, no different from characters like big or small. Elementary stage. Numbers represent object quantities. For example, I have 3 apples. Developmental strange. Numbers represent relationships between things. For example, 2 is smaller than 3. 8 o'clock comes before 9.
Advanced stage. Numbers can be compared and used in calculations.
Deep stage. Numbers become abstract symbols representing any quantity. Children typically reach elementary stage cognition around age 3. By age 6, they reach intermediate stage. By 9, the advanced stage. And by 12, should achieve deep abstract cognition. Sung Luhong conducted an experiment asking elementary students in China, Japan, and South Korea, what is the number 7? Children from these countries consistently tried explaining it through numerical definitions. 7, rarely did they connect it to real-life context to understand the number. By contrast, Australian students would say, it's the days in a week, how many dolls I own, my age, etc. These responses reflect children's varying ability to connect abstract concepts with concrete realities. Moreover, Australian children's problem-solving speed and accuracy lag behind Chinese children's. This process should align with the different developmental stages of a child's ability to understand abstract concepts. For children just learning to count, parents can have them inventory their belongings daily and keep records. Also, regularly measure the child's height and weight for comparison. When older, have them assist with family tasks while incorporating number concepts. For example, count how many types of items are in the fridge to establish unit concepts. While climbing stairs, count the steps. Notice the difference between climbing 3 steps, then 4, versus climbing 4, then 3. This is actually the difference between 3 plus 4 and 4 plus 3. This builds concepts of addition, subtraction, and the commutative property. When riding buses or subways, read each station name to establish sequence concepts. Activities like these effectively cultivate children's math thinking. For 6 to 8-year-olds, consider 2 examples from the book. The first relates to weight. Sun Luhong's family had a weighing scale. During the resource-scarce 1970s, scales were typically only found in business-owning households. His mom bought the scale wanting to be trendy, but it unexpectedly sparked something magical. To show 4th-grade Sun Luhong how scales worked, she weighed his backpack, books, pencil case, recorded everything, deeply impacting him. From that day, he weighed his backpack daily and every household item, cups, bowls, chopsticks, obsessively. Through weighing, Sun Luhong mastered numerous math concepts, First, he learned weight could be quantified numerically. Lighter objects had smaller numbers. Heavier objects had larger numbers. Actually, 6-year-olds can grasp weight and quantity through this experiment. Next came decimal concepts and units like jin and liang. Then, his mom had him weigh a water-filled bottle. 1 jin, 6 liang. She recorded it as 1.6 jin, then emptied it. The empty bottle weighed 8 liang with 0.8 jin, so the water poured out was 8 liang or 0.8 jin. Pure decimals are a vital, elementary math concept representing quantities smaller than 1. Many kids relying solely on classroom learning confuse decimals with small numbers like 1, 2, or 3. This is because just talking theory makes it hard for kids to grasp the real meaning. The scale at home ensured Sun Luhong never made mistakes on weight-related problems and even honed his special skill, accurately weighing small items by hand. Once, while handing a teacher a water cup, he casually mentioned its weight, so the teachers had him weigh all sorts of things in the office. The teacher's amazed and admiring looks gave the young him a huge boost of motivation. We don't have to copy this exactly. Use household items like thermometers or rulers with scales to turn knowledge and terms into tangible concepts in kids' minds, helping them overcome barriers. The first hurdle in math learning is grasping abstract concepts. After that, the rest flows naturally. The second example relates to the concept of equivalent substitution. The founder, Sun Luhong's diary, recorded these little stories. In summer at the store, his mom told him, if he chose popsicles, he could buy 3. If soda, only 1 bottle, because 1 bottle of soda costs the same as 3 popsicles. When preparing dinner, Sun Luhong could choose to eat baozi or jiaozi. If baozi, 5 would fill him up. If jiaozi, he'd need 30. These choices helped him understand equivalent substitution early on. Once, there was an application problem in a math test about equivalent substitution for buying pencils, erasers, and pencil sharpeners. Problem: Sun Luhong couldn't solve it, so his mom took him to the mall the next day. When he saw the 3 items displayed together and calculated their prices himself, he instantly understood the problem and how to solve it. Now, equivalent substitution is a key concept representing the transitivity of numbers in equations. In a broader sense, equivalent substitution can extend to replacing functions with functions, solving very complex math problems. But we can't explain it to kids by just reciting definitions and terms. They won't grasp the reasoning and might get more confused. If we can turn abstract concepts into something visible and tangible, kids' brains will automatically link concepts to reality, achieving a cognitive leap. Besides scales and popsicles, soda, Sun Luhong's mom used countless props to enlighten him, like segments of beans when picking vegetables, rice at home, and go boards. Props.
Once ready, let Sun Luhong play by himself.
Mom would timely pose some questions to guide his thinking. So, parents can usually look at their child's homework more often or silently note things down when helping with homework, identify where the child has difficulty understanding abstract concepts, and then think about what everyday items can be used as teaching aids. To help children understand, besides the right concepts and methods to cultivate math thinking, in the process of learning math, children also encounter many practical problems. Next, Part 3 introduces common problems and solutions in elementary school math learning. Fluctuations in learning status and grades in elementary school are normal. Each exam is an opportunity. What matters isn't the grade, but using the exam to clarify what the child has learned and understood. Sun Luhong's mom would always ask him some questions, even if he got a perfect score, like which problem took the longest time, and which one he was least sure about. After the exam, which problems did classmates discuss the most? Through these questions, parents and children can better recognize how well knowledge points are mastered and what issues need attention. And the first common problem is making mistakes due to carelessness. When children are careless, parents shouldn't blame them by saying things like, "How can you be so careless?"
You got such a problem wrong.
Such words won't make children more careful next time. They'll only make them nervous. For such problems, we can see if the child has already mastered similar types of questions. If they actually know how to do it, then don't dwell too much on mistakes caused by carelessness, as it's a normal phenomenon. Children in grades 1 to 3 make more careless mistakes. At this time, don't discourage them. Protecting their positive self-esteem is more important. Parents shouldn't punish children for careless mistakes, especially by assigning tasks like copying multiple times, which are simple, repetitive, and don't require thinking. And Boston, as long as the child understands why they made the mistake, you can remind them to pay attention next time they do problems. The second problem is making mistakes due to skipping steps or misusing rules while solving problems. Some children think too fast during calculations. They jump to the next step and skip the previous one. At this point, we can ask children to write down every small step when correcting, without skipping, to help them build a clear and definite process in their minds. Solving math problems requires applying many different rules: addition, subtraction, multiplication, division, area calculations, angles, and so on. If kids aren't familiar with the rules, they might apply the wrong ones.
This happens often in grades 3 and 4. When you spot this issue, ease up on speed demands. Focus on details to build a solid foundation. Use similar modified problems to help kids memorize steps and rules. Ease on one thing. 2 CPT. Try giving bigger paper and more time for solutions.
The third problem is misunderstanding the question. From fourth grade onward, errors from misinterpreting questions can exceed 35%. Textbooks and word problems introduce tons of new vocabulary at this stage, and teachers might not explain every term. Kids might guess their way to correct answers without truly understanding. Mistakes actually help expose issues so we can trace the root cause. Math isn't just numbers, it's vocabulary too. Key terms and word problems include half, double, identical, same, round trip, take turns, same direction, and similar. How do we explain these terms?
Parents should use everyday objects to demonstrate, even reenact problem scenarios. Never just read definitions or force rote memorization.
Only by mastering vocabulary can kids easily clear the hurdle of understanding questions. Research on gifted children shows their excellence lies in understanding abstract terms and relationships. Math prodigies especially possess unique comprehension of linguistic vocabulary. The more kids interact with concrete quantities in daily life and get timely parental guidance, the better they transition to abstract thinking. The final issue is unmastered concepts and knowledge points. For example, not knowing a triangle's angles sum to 180 degrees, or misusing commutative or associative laws in multiplication.
These problems need extra attention.
Unresolved concepts create future learning barriers. Solution: guide kids to verbalize their understanding and problem-solving process. Parents should listen without interrupting, asking questions to draw out their full reasoning. According to Sun Luhong's teaching experience, 85% of kids can grasp concepts themselves while explaining. Ideas they figure out on their own usually won't forget. Whether taught by teachers or parents, nothing stimulates the brain as deeply as self-discovery, helping them master concepts completely. Sometimes, when parents sit with kids studying, they see their eyes darting around, knowing they're thinking, but unsure if their thoughts are on the right track. Only after finishing the problem do they know if it's correct or not. Actually, this misses the best chance to understand the child. Getting them to speak their thought process out loud isn't difficult. Maybe it'll be slower at first, but building this habit helps them explore anything. That's the main content of the book Math Taught by Mom. Although the title says Mom, any daily caregiver can use it, like dads or even grandparents. Math is a subject that can impact a person's entire life, influencing thinking, making people more organized and rational in recognizing, judging, and handling things. Math education rooted in daily life has a deeper impact on kids. As the renowned German educator Diesterweg said, The art of teaching isn't about imparting skills, but about inspiring, awakening, and encouraging. Math Taught by Mom. That's our interpretation of this book. I hear the notes are below the audio, and we'll see you next time. Um, so